All right, so we're going to add and subtract radical expressions. And it says square root expressions with the same radicand are examples of like radicals. So, question for you. All right. Jordan, how come I could simplify question number 1 and question number 2? What allowed me to do that? Okay, same x and y stuff. And what do we call those specifically? Like terms, right? Okay. All right. We were able to add the x's together and the y's together on number 1 and the x, y's all together on number 2 because those are like terms. Well, when it comes to radicals, we can add them and subtract them also if we have what's called like radicals. In other words, if what's under the radical is the same, I can combine them. And I combine them just like I did these problems. Like number 1, I would do 14x plus 1x would give me 15x, right? So basically all I did is add 14 and 1 and got 15, and the x was my little nice piece I had to go with it, right? Okay. The same thing happens when we're adding and subtracting radicals. They have to be the same. So if you look at what we got right here in the red and blue, it says 2 square roots of 5 plus 4 square roots of 5. Okay. I could actually use the distributive property and write that as 2 plus 4 times the square root of 5. And we all know that 2 plus 4 is 6, so I have 6 square roots of 5. So what you look at is these things, if they're the same, then I just add their coefficients. Okay? All right, that's the number in front of them is called the coefficient. All right, just like up here we have like 2 oh, it's over there. Okay? All right, letter B, or the second one down here then. All right? We have 6 square roots of x, negative 2 square roots of x. The parts under the radical are the same, so I can add the numbers on the outside together or subtract them, whichever one it may be. So in this case, 6 minus 2 is 4 square roots of x. Okay. All right, so Sammy, using your extraordinary knowledge, okay, what's the answer to letter A? 5 square root of 3. That's extraordinary. Good job. Okay. Since these two things are the same, I can combine the coefficients, the numbers in front. Okay. All right. And it doesn't go away. There's still a square root of 3 there. This is just like if it said 9x minus 4x, you would say 5x. Same thing. Okay. All right. Letter B. Mr. Schultz, what's the answer to letter B? All right, Alec, help him out.
Don't combine them since they're unlike radicals.
So if I take my highlighter out, okay, I highlight this one yellow, and so any other ones that are yellow must be the square root of x, right? Oh, that's square root of y, so that's got to be green. Can I put yellow and green together? No. Can you add apples and oranges? If you want mixed fruit, you can, but we don't want mixed fruit, okay? We want just apples or just oranges. So this is the answer. It cannot be simplified, so that would be my answer. The things under the radicals have to be the same. All right, letter C, coming back to you, Mr. Schultz. All right, redemption. What's the square root of m minus 7 square roots of m? All right, everybody give him a hand. He got it right. Oh, man, it's not there. All right, equals negative 6 square roots of m. Very good. Okay. Letter D. Letter D. All right, Austin. Can you help us out here?
Okay. 13 to square root of xy squared to the square root of y, right? Right.
No, I'm sorry, that's not correct. Okay, now, first question is this, Austin. Which ones of those, so there's 3 terms up there, right? Okay, which of those 3 terms have the same thing under the radical? The first one and the last one, right? Okay. So if I take my highlighter or my pencil or whatever and I say, okay, this one's the same as that one, right? Okay. That means that I can only combine those 2 together. Okay. And 2 plus 9 is? Okay. So we get 11 square roots of xy. And there's nothing to go with this square root of y, right? So I just add that on to the end. And that would be my answer. Okay? Excellent. All right, you're going good. I think we got that. Now, sometimes we have radicals that we've got to simplify before we can combine them. So we're going to take all those skills you learned in the previous lesson, 11.6, with the skills you just learned in that lesson, example 1. So we have the square root of 45 minus the square root of 20. Alec, can I add them together? Or subtract them in this case? No, not as they are. Okay? But possibly I could simplify them so that I could. So I want you to simplify them. What'd you get for square root of 45? Okay. All right. So what did you get when you simplified it all the way? 3 square roots of 5 here, right? Square root of 9. Okay. Minus 2 square roots of 5, right? Okay. And 3 minus 2 is 1. Do I need to put a 1? Okay. All right. Square root of 5. Okay. Square root of 5. All right. Okay. Letter B. And that's the last one we're going to do today. Letter B. Because there's a very important thing here that I don't want you to miss. Angel? No. No. It is okay to put a 1 in front of it if you so desire. All right. Square root of 75. Hey, we just did that, didn't we? So this is 9 times 5 square roots of 3, right? 75 is 25 times 3. Square root of 25 is 5. Okay? Plus 2 times 5 square roots of 2. Right? Because 50 is 25 times 2. Okay? Now, here's where mistakes are made. Okay? Don't make this mistake. This little dot I put here means what? Multiply, okay? What happens is, and I don't want you to do this, but I know a couple of you will do this at some point in time. It does not mean add those numbers, and sometimes that happens, so don't do it, okay? When I get to this point here, it's multiplication. So this is 45 square roots of 3 plus 10 square roots of 2. All right? And at least a couple of you on a quiz will write 14 and 7. And it's not 14 and 7, okay? Multiply them together.